Hi friends, this is Naresh Ograla. I am here to discuss about the simplex method. Simplex method is one of the important method to solve the linear programming problems. So before start to discuss about the simplex method, let us understand what is linear programming and what are the different kinds of linear programming problem solving methods and how this simplex method can be solved. The linear programming is also termed as a linear optimization. It is a mathematical technique for finding the best possible outcome in the problem where both the objective and the constraints can be expressed as the linear functions of decision variables. Here the maximization and minimization. In business there are two important concepts we need to remember. One is about the cost, another one is profit. In the case of profit, every business holder wants to maximize their profit, and in case of cost, every manufacturer or a business in business perspective, they want to minimize their expenditure or else cost. As we given the definition or meaning of linear programming or linear optimization, this linear programming is having some important components. There are three important components. One is objective function, and the second one is subject to constraints, and third one is subject to restrictions. Objective function means the linear programming problem has some objective, that means to minimization of expenditure or maximizing the profit. And subject to constraints, the variables, the decision variables, what they are having the constraints, that means the limitation factors, also called scared variables or the scared resources. Subject to restrictions means to fulfill these objective function and constraints, we must follow the subject to restrictions. By using these components, the methods, there are three important methods to solve the linear programming. They are also called methods of linear optimization. The first method is formulation of LPP, and the second method is graphical method. And the third one is very important, what we are going to discuss is simplex method. So as I told you that objective function, if it can be denoted as max z or min z. Max z is in case of profit, min z is in case of cost. Whereas I am explaining that a linear programming problem, what is the structure of linear programming problem. As I mentioned that the three components, one is objective function, and the second one is subject to constraint, third one is subject to restrictions. So first, objective function. If I am considering the profit, then the objective function of profit is equal to the max z. It can be denoted by max z is equal to, let us take 2x1 plus 3x2. To achieve this objective, some subject to constraints. To achieve this objective or a profit as a profit, some constraints are to be there. For example, the constraint equations like x1, x2 is less than or equal to 200 plus 3x2 plus 5x2 is less than or equal to 500, and subject to restrictions, where here x1, x2, these variables should be positive. x1 is greater than or equal to 0, x2 is greater than or equal to 0. If the x1 is greater than or equal to 0 and x2 is greater than or equal to, then only we could solve these two constraints equations. Or else if the x1 is less than or equal to 0 or x2 is less than or equal to 0, the values will not be follow the linearity of these equations. So that if any linear programming may constitute this structure, one is objective function, and these two are called subject to constraints, and this one is called subject to restrictions. So for these kind of problems, this is the complete linear programming problem. For these kind of problems, we need to find the optimal solution, what we call optimal solution. For Finding the optimal solutions to this LPP, as I mentioned, the three methods are there. One is formulation of LPP, we did it, and through graphical method we will get the optimal solution, or the optimal solution also can be obtained by using the simplex method. In this session, I would like to discuss how to get the optimal solution of a linear programming problem by using simplex method. And in simplex method, there is to solve a problem, LPP problem, there is a procedure. Let us see how many steps it has and what is the procedure of the linear simplex method. There are 6 steps. The first and foremost step is establish a given problem, that is write inequality constraints and objective functions. That means we have formulated one linear programming problem, just like here we formulate the linear programming problem with inequality constraints. And the second step is convert the given inequalities to equations by adding the slack or surplus or artificial variables to each inequality expression. It means the inequality expressions are simply that should be remove the less than or equal to or greater than or equal to symbols. How could we remove these symbols like less than or equal to, greater than or equal to symbols? By adding some slack variables. He's mentioned slack variables or surplus variables and artificial variables. What is slack variable and when it should be added? What is artificial variable, when it should be added? Let us see. See here, the three variables: slack, surplus, artificial variables. If the inequality be less than or equal to, if the inequality is less than or equal to, then we should add slack variable. The slack variable will be denoted by plus s and to change into the equation. Whereas if the inequality be greater than or equal to, if there is a inequality greater than or equal to, then we should subtract a surplus variable, that is denoted by minus s. When we are adding minus s, then it can be changed into an equation, that means equal to some value. If we have equal to, not less than, not greater than, if we are having equal to, then it is called, we should add artificial variables. If in case maximum, we know that less than or equal to is there. In minimization, greater than or equal to 0 or greater than or equal to some value. If the less than or equal to value is existed, then we should add slack variables. If the greater than or equal to 0 value is there, then we should add surplus variables. Okay, and after adding these equations, the third step will be gone. Create an initial simplex table and write the objective function at the top row. Here what happened, each inequality constraints appears in its own row. I'll show you that initial simplex table, how it is going to be there. See, this is the initial simplex table. We have formulated objective functions row and their corresponding values will be written here and their other values will be written. Solution means after less than or equal to value. For example, here this is called the solution. This is called solution values. And these variables can be removed. If it is less than or equal to 0, then how the equation can be changed? X1 plus x2 plus s1 is equal to 200. Slack variable is added because less than or equal to 200. Likewise, we should formulate the initial simplex table. And after formulating initial simplex table, it will be converted into the augmented matrix. That means if there are two variables, then the augmented matrix means 1 0 0 1 should be observed. I will explain you in this this augmented matrix or unit matrix how it will becomes during the example. And in the fourth step, identify the greatest positive entry in the bottom row, which helps to identify the pivot or key column. After subtracting the value of zj from cj, we will get some values here. We will get some values here. If the value cj minus zj value is less than or equal to 0, the problem is obtained as optimal solution. We reach the optimal solution. If the values of cj minus zj is not less than or equal to 0, that means greater than or equal to 0, that is not an optimal solution. We should go for next step. So if once I got the greatest value, there is a no less than or equal to value. If I got some two positive values, we should consider the greatest positive entry at the bottom row. The corresponding column will be called key column. And similarly, if we will get the key column, we need to find the key row. The key row, how will you get? Divide the solution column, and whatever the values you are attaining, written here solution column, these values should be written with divided with the key column. Then you will get the ratio value. Ratio column, if the values are 0, ratio column, the values are 0 or negative, we should not consider them as a key row or anything else. And fifth step, write the new row or key element row by dividing existing row with the key element. And for other rows, we need to apply the following formula. So the new value can be identified by this formula: old value minus corresponding key column value into corresponding key row value divided by key element. Once we find that, zj value will be founded, and cj minus zj. Cj minus zj, if it is less than or equal to 0, for maximizing case we reach the optimal solution. If cj minus zj greater than or equal to 0, minimization case, we will reach the optimal solution. If it is not there, we need to continue until we will get the optimal solution. Now, based on this procedure, let us discuss one example problem of simplex method. So here is the example problem. Find the optimal solution for the following LPP by using simplex method. Here it is a max z, that means a profit case. The max z is equal to 40x1 plus 30x2, and the subjective constraints are x1 plus x2 less than or equal to 12, 2x2 plus x2 less than or equal to 16, and the subjective restrictions are x1 greater than or equal to 0, x2 greater than or equal to 0. Now, as per the procedure, the first step is, what is the first step? Establish the given problem, write the inequality constraints and objective functions. Yes, I have formulated, and the given problem is LPP, formulated the inequality constraints with objective function. And the second step is, what is the second step? Convert the given inequalities to equations by adding slack, surplus, artificial variables to each inequality expression. So here, what should be added? Whether it should be added a slack variable or surplus variable or artificial variables. As we've seen that artificial variables and surplus variables, the condition we know that. What is that? If inequalities be less than or equal to, then what should be added? Plus s. See how the equations can be written as. Convert the given LPP into standard form. The standard form of this equation is max z is equal to 40x1 plus 30x2. I am adding slack variables 0s1 plus 0s2. Here, when I am adding 0s1 is 0, 0s2 is 0. The original equation is not changed. Just for removal of inequality constraints, I am adding the slack variables. Then what the subjective constraints will be converted into standard form, x1 plus x2. First constraint is s1. So first slack variable for equation 1 is s1. is equal to, what is the value? 12. And for second constraint I am adding s2. s2 is there here. 2x1 plus x2 plus s2 is equal to 16. Now the subjective restrictions are x1 comma x2 comma s1 comma s2 are greater than or equal to 0. This is the finally what we have converted the inequality equation into the standard form. Then we need to go for step 3. What is the step 3 here? Step 3 is create the initial simplex table and write the objective function at the top row, and the inequality constraints appears in its own row. Let us formulate one initial simplex table. Just I am writing the initial simplex table. You know that as I shown you that initial simplex table, this table represents the cost variables. This is a cost of basic variable and basic variable. In initial simplex table we should represent the basic values, like s1 and s2 will be written as a basic values, and corresponding costs. The corresponding costs can be written as 0s1 and 0s2. I'll show you here. Whereas if the equations are turned into this one, if I write these equations, objective function of the equation is, what is objective function? 40x1 plus 30x2 plus 0s1 plus 0s2. So I am written here x1, x2, s1, s2. Now objective function, then corresponding cost of basic variable, x1 variable cost is 40, x2 variable cost is 30, s1 variable cost is 0, s2 variable cost is 0. So x1 40x1, 30x2, 0s1, 0s2, right? Similarly, the first constraint equation here, 1x1, 1x2, 1s1. Here 1x1 plus 1x2 plus 1s1. There is no s2 here, right? Just I am writing 0 instead of s2. For the cost of basic variable, s2 is 0 for first constraint, and similarly for second constraint, x1 variable is 2, x2 variable is 1. Is there any s1 here? No. So that we have to return 0. We have to write here 0, and then for s2 is there. For that s2 we need to write here 1, and equal to, what is the value here? 16. This is a formulation of initial simplex table. What is this? Initial simplex table. And ZJ. How could we find the ZJ? ZJ can be find multiplication of cost of basic variable with the basic variables. 0 into 1 plus 0 into 2. 0 into 1 0, 0 into 2 0. So 0. 0 into 1 plus 0 into 1 0. 0 into 1 plus 0 into 0 0. 0 into 0 plus 0 into 1. So here it is also 0. And similarly 0 into 12 plus 0 into 16, 0. Now what should we find to get the optimal condition? That is here in the procedure. How could we get the optimal solution? If the Cj minus Zj less than or equal to 0 for maximum case, then the optimal solution attained. For this we need to find Cj minus Zj. What is the value of Cj here? 40, 30, 0, 0. Now corresponding 40 minus 0, 40, 30 minus 0, 30, 0 minus 0, 0, 0 minus 0, 0. Now let us go to the optimality condition. What is optimality condition here? For maximization case, Cj minus Zj should be less than or equal to 0, and minimization case Cj minus Zj greater than or equal to 0. Until to get the value of Cj minus Zj less than or equal to 0 in maximization case, we need to continue the process. And similarly in minimization case also, to get the optimal solution, the final Cj minus Zj should be greater than or equal to 0. Now let us see. See, Cj minus Zj. Here it is positive, not less than or equal to 0. It is 30. It is also not less than or equal to 0. It is equal to 0, it is equal to 0. So what the condition here? If there are two positive values, what value to be considered is here? In the step 4, identify the greatest positive entry in the bottom row. In the bottom row, greatest positive entry is here, it is 40. So that this value is, this column is considered as key column. What is this? Key column, or also called pivot column. Key column or pivot column. After finding the key column, we need to divide the solution column with the key column. That means 12 divided by 1 is equal to 12. 16 divided by 2. What we get? 8. For this case, what is the reason behind to find the ratio? Is to find the key row. What is the key row? Here to find the key row, we should find value of minimum value in the ratio column. Key column, find the minimum value as a key row. Whatever the value is minimum, that will be considered as key row. This is called key row. And the value 2, the point where, or the value where key column and key row is intersected, is called key element. Key element. Have you find that? Key column. Here the column is key column and the key row. In key column case, we find that maximum. In key row value, we find that minimum. If the value is minimum in key row, that is the, in ratio column, that is the key row. Okay. Now, if the value is not Cj minus Zj less than or equal to 0, then we need to go for another simplex table, that is called iteration 1. And the same, we need to draw the same table here, the template form, and find the new values here. So for iteration 1, the new table can be written as, here the same, the variables what we have mentioned in this one will be written at the top of the iteration 1. Here x1, x2 and s1, s2. So if we write the empty form, see iteration 1 table like here, x1 values will be same at the top, 40x1, 30x2 and 0s1 and 0s2. Now what the values will be changed? This process, iteration 1 process and iteration 2, how many process you may consider, the values of unit matrix should be observed, 0 1 1 0, 0 1 and 1 0. Now to write this key row new value, the leaving variable and entering variable, the leaving variable is s2 and the entering variable is x1. Here how should we write? Instead of s2 we need to write x1, the x1 corresponding corresponding cost is 40, that will be written here, and the first one is S1 is common and it's 0. Here this is the leaving variable and this is x1 is the entering variable to here. Why it is happening? The key row, once the key row will be leaving variable, key column will be entered into where the key row is leaved or left. So that how to write the new value? Here this new row value can be written as divide the entire row with key element. That means 2 divided by 2, 1 divided by 2, 0 divided by 2, 1 divided by 2 and 16 divided by 2. Divide the key row with the key element. Then we can write the new row. That means 2 divided by 2, 1, and 1 divided by 2. Here 1 divided by 2. 0 divided by 2 means 0. Here 1 divided by 2, that means 1 divided by 2. 16 divided by 2, that means 8. Okay. Now other than key row, new row value will be finded using the formula, and in the process we have seen that the new row values will be finded using the following formula. New value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. I will explain you each and every value how to find it. You remember this formula. New value is equal to old value minus corresponding key column value into corresponding key row value divided by key element. If I write the values of new row by using this formula, I will show you here to calculate the values. First, what is the value here? What is the value? First value is 1. 1 minus, for one value, old value is 1. Old value is 1 minus, what is the formula here? Corresponding key column value. Here the key column is here. Key column is here is that, and the corresponding key column is also 1 into corresponding key column value is 1 and corresponding key row. This is the key row. For this value, corresponding key row value is 2 divided by the key element is the point where intersecting the key column and key row is key element, as we written here. That should be divided by 2. 2 will be cancelled, that is equal 1 minus 1, 0. We need to write, instead of 1, we should write 0 here. And similarly, next value, here is old value is for new one. 1 is here. Old value minus 1 minus corresponding key column value 1 into corresponding key row value 1 divided by key element 2, that is equal to 1 minus 1 by 2, that is equal to 1 by 2. We should write this 1 by 2 value here, and next value is 1 here. Old value 1 minus corresponding key column value 1. For the value 1, corresponding value is 1, corresponding key row value is 0 divided by 2, that is equal to 1 minus 0 by 2. 0 by 2 is 0, 1 minus 0 is equal to 1. Instead of this one, write the value 1 here. And next, here the next value is 0. 0 minus corresponding key column value 1 into corresponding key row value 1 divided by key element 2, that is equal to What is the value here? Minus 1 by 2. Write this minus 1 by 2 instead of 0. Minus 1 by 2. And now for this, the old value is 12 minus corresponding key column value 1 into corresponding key row value 16 divided by key element 2, that is equal to 12 minus, here it is 8 times 12 minus 1 into 16 by 2, 12 minus 8, that is equal to 4. Write the 4 value in the place of 12. The value is like this. Now the same procedure, go to the value of ZJ value. How will you get the ZJ? 0 into 0 plus 40 into 1. The value is 40. 0 into 1 by 2, 0 plus 40 into 1 by 2, 20. Next 0 into 1, 0 plus 40 into 0, 0. 0 into 1 by 2 plus 0 into 1 by 2, 0 plus 40 into 1 by 2. That means 20. 0 into 4, 0. 40 into 80, 320. Now what we need to find? Cj minus Zj. Cj minus Zj. 40 minus 40, 0. 30 minus 20, 10. 0 minus 0, 0. 0 minus 20, minus 20. So ఇక్కడ Cj minus, here 0 Cj minus Zj, not all are less than or equal to 0. One positive number is there. So it will be the entering variable, or that is also called key column value. Now we need to find the key row. Given that key row we need to find. How to find the key row? Divide the solution column with the key column. Then divide the values. Key column values should be divided. See, 4 divided by, here this is 1 by 2. If we get it 1 by 2, the 2 will comes to the numerator, then it will be written as 8. And similarly 8 divided by 1 by 2. So the 2 will be under numerator. 8 into 2, that is equal to 16. Just I am writing here 16. Which is the smallest value in the two ratio values? 8 is the smallest value. So this 8, the corresponding smallest value row is called key row. That means this is the leaving variable. That means S1 is the leaving variable, X2 is the entering variable. Now we need to formulate the new simplex table. Then iteration 2 is formulated. Iteration 2. As like in the iteration 1 table format, I have written this, and here is Zj. Now write the given variables. What should be leaving variable, what should be entering variable. The entering variable is X2. Where should be enter here? In the place of S1. And the S2 is common. In S2 place, here is X2. Instead of X1, we need to write X2 here. Instead of S1, we need to write X2 here. Just I have written X2. And X1 is common. So if X2 I am written here, the corresponding X2 variable cost is 30. And X1 is common. X1 and its corresponding cost is 40. Now as per the previous rule, if we want to write this new row, what did we done? Divided the key element, divided the entire row with the key element. Similarly, in this one also, divided the key element is here 1 by 2. divide the entire row with 1 by 2. Then we will get the corresponding, this x1 is replaced with x2, s1 is replaced with x2. In this here 0 by 1 by 2, that means 0, and next 1 by 2 divided by 1 by 2, that means 1. 1 by 2 divided by 1, see here 1 by 2 divided by 1 by 1 by 2, so the 2 will be into the numerator. The value can be written as here 2. And similarly the next value 1 minus 1 by 2 divided by 1 by 2, that means minus 1. Next 4 divided by 1 by 2. How can we write 4 divided by 1 by 2? Then what happened? 4 into 2 by 1, that is equal to 8. This 4 value should be replaced with 8 in solution column. Now to find this new row value, the formula is to be applied. What is the formula? New value is equal to old value minus corresponding key column value into corresponding key row value by element. We need to apply the formula for each and every value in the other than key row. So what the values will be comes here. What is the first value? 1. That is equal to 1 minus corresponding key column value. Corresponding key column value is 1 by 2. Corresponding key column value is 1 by 2 into key row value. Corresponding key row value, this is key row. Key row value is 0 into 0 by key element is 1 by 2. 1 by 2 or something, 1 by 2 is cancelled and 1 by 2 cancelled, that is equal to 1 minus 0, the value is 1. So just I am writing here the value is 1. And similarly the next value, what is the next value here? 1 by 2. 1 by 2 old value minus 1 by 2 old value minus corresponding key column value is 1 by 2 into corresponding key row value is 1 by 2 divided by corresponding key element. Key element is 1 by 2. This 1 by 2, this 1 by 2 cancel, that is equal to 1 by 2 minus 1 by 2 equal to 0. Instead of 1 by 2 we should write 0. Instead of 1 by 2 we should write here 0. See here the unit matrix is came here 0 1 1 0. Unit matrix is came here 0 1 1 0. Now we will get the optimal solution directly. That is a one fundamental difference. If once you reach the unit matrix 1 0 1 1 0 for two variables, the values next to upcoming values Cj minus Zj will be the less than or equal to 0 or optimum solution. Let us check it out. That is a remembrance of a fundamental thing in this process. Next value 0. Next value is 0 minus corresponding key column value 1 by 2 into corresponding key row value 1 divided by key element 1 by 2. 1 by 2 cancel, that is equal to 0 minus 1. 0 minus 1 minus 1. Here instead of 0 what should be written? Minus 1. Instead of 0 we should write minus 1. And next corresponding old value is 1 by 2 minus old value is 1 by 2 minus, where is it? 1 by 2 minus corresponding key column value 1 by 2 into and corresponding key row value minus 1 by 2 divided by key element is 1 by 2. This 1 by 2, this 1 by 2 is cancelled. That is equal to 1 by 2 minus into minus plus 1 by 2, that is equal to 1. So instead of 1 by 2, the new value should be written as 1. Instead of this 1 by 2, the new value should be written as here 1. And similarly for 16. For 16 I am calculating here itself. Old value is 16 minus corresponding key column value 1 by 2 into corresponding key row value 8 divided by key element is 1 by 2. 1 by 2 1 by 2 will be 1 by 2 1 by 2 will be cancelled. 16 minus 8, that is equal to 8. And sorry, we have considered the 16, that is not a solution table, ratio table. What is the old value here? It is 8. 8 minus corresponding key row value is 4 into corresponding key column value 1 by 2 divided by, and key element is 1 by 2. 1 by 2 1 by 2 will be cancelled. 8 minus 4 is equal to 4. So instead of 8, what should be written here? 4. So we have get all the new row values. Now what should we find? ZJ value. ZJ value will comes CB value into x1 plus CB value into x1. 30 into 0, 0 plus 40 into 1. Here 40. 30 into 1, 30 plus 40 into 0, 0. 30 plus 0, 30. And similarly 30 into 2, 60. Plus 40 into minus 1, minus 40. 60 minus 40, that is equal to 20. Here I am writing 20. 30 into minus 1, minus 30 plus 40 into 1, 40. That means 10. And here 30 into 8, 240 plus 40 into 4, 160. That is equal to 400. That is equal to 400. Now Cj minus Zj. 40 minus 40, 0. 30 minus 30, 0. 0 minus 20, minus 20. 0 minus 10, minus 10. So here once you observe these values, Cj minus Zj, all values are less than or equal to 0. It means either negative or values are 0. So we reached the optimal solution. Optimal solution. What is the value or what is the optimal solution value of the given LPP is? How could we find it is where x1 is equal to 40 and x2 is equal to 30. If once we substitute the x1 is equal to 4 and x2 is equal to 8. If once we substitute x1 is equal to 4, x2 is equal to 8, then we will get the optimum value, that is max z. The optimal solution is equal to max z is equal to, what is the equation actually here? 40x1 plus 30x2. 40x1 plus 30x2. Here the corresponding x1 value, what you did get here? 40. Substitute that one. 40 into x1 is 4 plus x2 value is 8. That means 30 into 8. See here, 160 plus 240, that is equal to 400. Max z is equal to 400 is the solution, optimal solution. This is the way what we will get the solution by using simplex method for LPP. Thank you all.